Hello everyone. You are listening to Professor Rajendra Tadakhe, Department of Mechanical Engineering, Marathwada Mitra Mandal, College of Engineering, Karvenagar, Pune. And I am course instructor for Theory of Machine 1. So in today's lecture, we are going to focus on the velocity analysis by the instantaneous center method. Basically, there are two different methods for the velocity analysis, that is analytical methods and the graphical methods. So under graphical method, we are having the instantaneous center method and the relative velocity method. So these two different methods we are having under the graphical method. So in today's lecture, we are going to focus on the instantaneous center method. So before we apply the instantaneous center method for the velocity analysis for the given mechanism or for given configuration of the mechanism, we have to study some basic concept. So we will go through all those basic concepts. So first we will go through some introductory part, then we will see what is basic definition of instantaneous center, then next we will study different types of instantaneous center briefly, then we'll learn to calculate the number of instantaneous center for the given mechanism. Then once we get an idea on calculation of number of instantaneous center for the given mechanism, then we will try to locate those instantaneous centers with the help of observation and with certain graphical procedure. And finally, we will practice some numericals from the previous university question papers and some practice problem based on actual application. Now moving to the basic definition of instantaneous center of rotation, we have to understand some basic things. So just to understand this, let's consider we are having this link AB. Now this link AB is moving along a straight line and acquires a new position, that is A1 P dash. Now from initial position A B to the final position A1 B dash, so during this the link AB is having pure linear motion or the motion which is along a straight line. Now what we will do, we will fix point A1 and will move point B dash to B1. So we have fixed point A1 and B dash is moved to B1. So during this, link AB is having a rotational motion. So now if we consider the motion of link AB from the start to the end, then it is a combination of two different types of the motion, that is linear motion and the rotational motion. But there exists in this plane, there exists some point about which the link AB is having purely rotational motion, though it is a combination of linear motion and the rotational motion. But I repeat, but there exists a one point in this plane about which the link AB is having a purely rotational motion, and that point is called as instantaneous center of rotation. And the important point to note that it does not remain constant. It keeps on changing from one instant to the other. So for all the configuration of the mechanism or for all the different position of the link AB, you will find the different instantaneous center of rotation. So if we take 10 different configuration or 10 different position of the link AB, then we will have 10 instantaneous center of rotation. And if we join all those instantaneous center for 10 different configuration, then we get one curve joining all the locus, then joining all the points, then that locus is called as centroid. So that is the basic definition about the instantaneous center of rotation. Now next we will move to the what are the different types of the instantaneous centers. So basically we are having three different types of instantaneous center. The first one is the fixed instantaneous center, then second one is permanent instantaneous center, and third one is neither fixed nor permanent instantaneous centers. Now just to define these three types, the name is enough. The first one is fixed instantaneous centers, which simply tells that it is fixed in nature. Then second is permanent instantaneous center. Again, name itself tells that it is permanent in nature, but there might be a small confusion between fixed instantaneous center and the permanent instantaneous centers. So for that we will look at their basic definition. So fixed instantaneous center, they don't change their position for all the configurations of the mechanism. So to understand this, let's consider this 4-bar mechanism ABCD. So for this mechanism, I12 and I14 are the fixed instantaneous center. Means for all the configuration, the position of I12 and I14 is not going to change at all. That is why it is called as the fixed instantaneous centers. And when it comes to the permanent instantaneous centers, then for this mechanism I23 and I34 are termed as the permanent instantaneous center. Then what is the difference between this fixed instantaneous center and the permanent instantaneous centers? Then we can see that if the configuration of the mechanism changes, I12 and I14 which are fixed, they will remain at point A and D. Okay, but when it comes to the permanent ICR I23 and I34, they will remain at B and C, as the joint are of permanent in nature. But if the configuration changes, let's say it is initial configuration is link AB is let's say it is making an angle of 60 degree with the fixed link. If the point B goes to this position, then I23 will come to this position, then at the same time I34 will go at this location somewhere. Okay, so that is the difference between permanent instantaneous center and the fixed instantaneous center. Then coming to the neither fixed nor permanent instantaneous centers, we can say that they vary with the configuration of the mechanism. Means, let's say this angle is 60 degree, that is AB is making an angle of 60 degree with the link AD. So this I24 and I13 are called as the instantaneous centers, which are neither fixed nor permanent instantaneous center. Means if this angle is 60 degree, next if I make is 61 degree, then I24 and I13 will go to the next position. Again if I make 61 to 62, again I24 and I13 will go to the different position. So that is the meaning of neither fixed nor permanent instantaneous center. They vary with the configuration of the mechanism. Okay, so for all the configuration of the mechanism we will get different neither fixed nor permanent instantaneous centers. So the next is how to calculate the number of instantaneous center for a given mechanism. So we have a simple formula. So with the help of that formula, we will calculate the instantaneous centers for the given mechanism. So we are not going into the depth of that formula. So directly we will use that formula to calculate the instantaneous centers. Okay, so this is the formula to calculate the instantaneous centers for the given mechanism, which is capital N is equal to small n multiply small n minus 1 divided by 2. So this is the basic formula with the help of which we can calculate the number of instantaneous centers for the given mechanism. Okay, so once we calculate the instantaneous center of the given mechanism, then the next process comes is the location of those instantaneous centers. So here is the meaning of capital N and the small n. So we will perform one example to calculate how we will perform one example on the calculation of the instantaneous center for the given mechanism. So let's consider one 4-bar mechanism ABCD. So for this mechanism, we will calculate the how many number of instantaneous centers this mechanism is having. So first of all, to calculate the instantaneous center, we need to calculate, or we need to count how many number of links are there for the given configuration. So let's first count the number of links. So AD, it is fixed, so it is link number 1. Then AB is link number 2, which is crank. Then BC is link number 3, which is connecting a connector or a coupler. And then CD, which is link number 4, which is called as lever. So how many links we are having in this configuration? 4. Yes, we are having total 4 number of links in this configuration. Now we have to put the value of small n as 4, and we have to calculate the value of capital N. So this is the answer. So we get the value of capital N as 6, which indicates we are having 6 instantaneous center for this given configuration of the mechanism. Now we will try to understand what are the various steps involved in the location of the instantaneous center with the help of the example. So we are having a simple numerical to understand the process for the location of instantaneous center. So what we are having here is we are having this 4-bar mechanism. So dimension of all the links are given here. AB is 20, BC is 30, then CD is 32 centimeter, and AD is 60 centimeter. Then AB is the crank, which is rotating at a uniform speed of 300 rpm in the clockwise direction. When the crank AB has turned 60 degree, means the position of the crank AB with respect to the fixed link AD is given, which is 60 degree. Then during this we have to locate, or at this instant we have to locate all the instantaneous centers and find the angular velocity of the link BC. So as discussed in the first slide itself, the purpose of instantaneous center method is to calculate the velocity of the different link or the specific point on a particular link. That is velocity analysis. So that is why it is asked in the numerical to find the angular velocity of the link BC direct. That is, we have to calculate omega BC. So this is our problem statement, and this is the given configuration. So we will proceed for the solution. So first of all, we have to write the given data from the numerical. So read the problem statement very carefully and extract all the given data in the required format. Okay, so the speed of the crank of AB is given, which is 300 rpm, and dimensions of all the 4 links are given. So those are marked, and the angle of crank AB with respect to the fixed link AD is given, which is 60 degree. And what we have to do is we have to locate all the instantaneous centers when the crank AB is making an angle of 60 degree with the fixed link, and finally we have to calculate the angular velocity of link BC. Fine. Now the first step is we have to draw the configuration diagram. So what exactly configuration diagram, that we will understand first. Configuration diagram means we have to draw the given mechanism with the given dimensions. So here we are drawing the 4-bar mechanism with the given dimensions. So here ABCD is the 4-bar mechanism with the dimensions as AB 20 centimeter, BC 30 centimeter, CD is 32 centimeter, and AD is 60 centimeters. AD is the fixed link, and the angle of crank AB with respect to the AD, that is fixed link, is given as 60 degrees. So that is why it is marked as 60 degree. Okay, so many of the students get confused while drawing the configuration diagram. So let me explain it in detail how to draw it. Let's say we are having this dimension. So these dimensions are too large for the half imperial sheet. So what we can do, you can scale down the dimension. Okay, so you can take the scale down, or you can scale up if the dimensions are too small. Okay, let's consider dimensions as it is. Okay, so first of all, draw this line AD, which indicates the fixed length of 60 centimeter. Then keep the center of protractor at point A and measure an angle of 60 degree. Then mark the angle of 60 degree, and from point A, or take A as a center and radius of 20 centimeter, mark the arc. So radius is equal to 20 centimeter and angle 60 degree. We can draw the AB. Then we will get the point B. So once we get the point B, then we are having a 30 centimeter length link and 32 centimeter length link. So what we have to do is, with the help of these two dimensions, we have to locate point C. So now take the radius of 30 centimeter in the compass, then put one point of compass on point B and mark the arc of a 30 centimeter. Similarly, put the compass on the point D, take a radius of, or take a distance of 32 centimeter and mark the arc of 32 centimeter radius. So the intersection of both the arc will give you the point C. That is how we draw the configuration diagram. So it is very important to understand how to draw the configuration diagram, because your entire things depends on the configuration diagram. If you make a mistake in drawing the configuration diagram, entire thing will go wrong. Okay, so I request everyone to draw the configuration diagram very carefully. Okay, so almost we have done with the 20% work. We have drawn the configuration diagram. Next, the part is we have to calculate, or we have to find how many instantaneous centers this configuration is having. So for that we have to count how many number of links this mechanism is having. So let's count the number of links. So AD is fixed link number 1, then AB link number 2, 3 and 4. Yes, we are having total 4 links in this mechanism or in this configuration. So already we know the formula to calculate the number of instantaneous centers. So by using that formula, capital N is equal to small n into n minus 1 by 2. Now put the value of n, that is small n, which is the number of links. So once you put the value of this small n, we get the total number of instantaneous centers for this configuration. So we are having 6 instantaneous centers for this mechanism. Now once we get the total number of instantaneous centers, the next step comes is we have to make the list of all those 6 instantaneous centers. So let's make the list of all 6 instantaneous centers. Okay, so how to make this list? That is very important. So in the first column, write links. Then let's say for this mechanism we are having 4 links. So number as 1, 2, 3, 4. Then we, in the second column, write instantaneous center of rotation. So take link number 1 and in the first pocket write I1, 2. So when we are taking 1, that is link number 1, keep it as fixed for the first row. Okay, so this during this we have to keep link number 1 as a constant and we have to keep changing the second digit. So here I12, so here I13. Again look at this, 1 is constant, after 2 there is 3, so I13, and again here I13. So similarly when we go for the second link, keep 2 as a constant and keep changing the second digit. So here I23, I24. Then again for link number 3, I34. So how many ICRs we are having here? 1, 2, 3, 4, 5, 6. Yes, we are having total 6 ICR and we have made the list of 6 ICRs. Next, we have to locate the ICRs by observation and by some graphical construction. So already we have seen in the types of ICR, there are some instantaneous centers which we can locate by observation. Okay, so basically the fixed instantaneous centers and the permanent instantaneous centers we can locate with the help of observation or just by observation only. So here I12 is the fixed instantaneous center, so we can locate by observation. Then I14, I14, here it is I14. Again, it is a fixed instantaneous center which we can locate by observation. So we have located two fixed instantaneous center, I12 and I14. Then next, at point B, we are having I23. So here we are having I23, which is permanent instantaneous center. Again at point C we are having I34. So out of 6, 4 instantaneous centers we have located by observation. Out of those 4, 2 are fixed and 2 are permanent in nature. Now we have left with 2 instantaneous centers, that is I13 and I24. So these 2 instantaneous centers are called as neither fixed and nor permanent instantaneous centers. So we have some specific graphical procedure to locate these 2 instantaneous centers, that is I13 and I24. So to perform or to locate the position of these 2 ICRs, what we have to do is draw a circle of any radius. You can choose the radius very randomly and you need not to draw a perfect circle. This is just rough construction you can make, but don't forget it carries the weightage. Okay, now we have to mark the point on the circumference of the circle. But again question comes, how many points we have to mark? Okay, definitely I will answer your question. So we have to mark the number of points on the circumference of circle equal to the number of links in the given configuration. Okay, so look at this configuration and tell me how many number of links we are having. 4. Exactly, we are having the 4 links in this configuration. So mark 4 points on this configuration or the circumference of the circle. So 1, 2, 3 and 4. So we have marked 4 points corresponding to 4 links in the given configuration. So next step is we have to join the points by the dark lines which will indicate the instantaneous centers. Those are already located in the configuration. So I12, yes, we have located. So join I12 by dark lines. Then 2, 3, yes, we have located 2, 3. So join 2, 3 by dark line. Then 3, 4, yes, we have located 3, 4. So join 3, 4 by dark line. Then 1, 4, yes, we have located 1, 4. So join 1, 4 by dark line. Okay, so 4 ICRs we have located, we have made 4 dark lines. Okay, that's done. Now what about I13 and I24? So let's say here we are having 1 and here we are having 3. So to locate 1, 3, join these 2 points by dotted lines. So we have joined point 1 and point 3 by the dotted line which represent the ICR I13, which is neither fixed and nor permanent. Okay, so what it does, it is dividing this quadrilateral into the 2 triangles, that is 1, 2, 3 and 1, 4, 3. So 2 sides of each triangle represent the 2 instantaneous centers. So here triangle 1, 4, 3 is representing 2 ICR, that is 1, 4. So this is I14 and 3, 4. So this is 3, 4. Again, if I go for the second triangle I23, then again it is representing two instantaneous centers, that is 1, 2. So here we are having I12 and again 2, 3. So here we are having instantaneous center 2, 3. So how to locate I13? So here we are having the basic Kennedy's theorem. So what Kennedy's theorem says, if we are having three relative bodies moving with respect to each other, then they are having three instantaneous centers located or which lie on the same straight line. So with this principle we have to proceed. So let's take 1, 4 and 3, 4. So what we have to do, where we are having 1, 4 and 3, 4, so we have to draw a line through this. So we can use a dotted line. So yes, we have drawn the line which is passing through the 1, 4 and 3, 4. Now next one is 1, 2 and 2, 3. Where is 1, 2 and 2, 3? Yes, here it is, we are having 1, 2 and here we are having 2, 3. So similarly as that of 1, 4 and 3, 4, draw the line passing through the 1, 2 and 2, 3. I12 and I23. Okay, yes. So both the lines are intersecting at this point. So this point of intersection is nothing but the instantaneous center, which is neither fixed nor permanent in nature. So this is I13. So we have located I13. So let's strike out it from the table. So now we are left with the only one instantaneous center, that is I24. So how to locate this? Exactly same as I13. So join 2 and 4 by dotted line. Okay. So again it is making the two triangles. Again each side of a triangle, each dark side of a triangle representing one instantaneous center. Here it is representing 1, 2, 1, 4, 2, 3 and 3, 4. Okay. So likewise through 1, 4 and 1, 2 draw one line. Then from 2, 3 and 3, 4 draw one line. Then intersection of both will give you the instantaneous center I24. So we have located I24. So strike it out from the table. So if you look at the table, we have located all the instantaneous centers. Now you may get a question that why we are extending this line on this side, why not on this side? So if you are locating on this side, they are not going to meet at all. They are departing from each other. Similarly, in this case, while locating I13, if you are extending this line on this side, then these are again departing line. They are not going to meet each other. The distance between these line will go on increasing continuously. That is why we have extended these lines on this side. So that's why we are getting I13 and I24. So this is how we have located the instantaneous centers which are neither fixed nor permanent. So again I repeat, after making the table, we have to locate fixed and permanent ICR by observation and neither fixed and nor permanent ICR by using this circle. Now we have to calculate the angular velocity of the link BC. Okay, so again it is very easy to calculate the angular velocity of the link BC. So we have to use the angular velocity ratio theorem. So by using that theorem, we can calculate the angular velocity of the link BC. So in general, we write the angular velocity of link X to the angular velocity of link Y is equal to I1Y upon I1X into IXY upon IXY. Okay, which is equal to, so omega X we have to take as omega 2 and omega Y we have to take as omega 3, because omega 2 is known as the value of speed of crank AB is given. So from this we can calculate the value of omega 2. So as the omega 2 is known, we can calculate the omega 3. So omega 2 upon omega 3 is equal to I13 upon I12 into I23 upon I23. So omega 2 by calculation is 31.41 radian per second upon omega 3. Then I13 and I23. So 13, where is 13? 13, and where is 23? Here is 23. So we have to measure this distance and we have to put here. Then 12 and 23. 12 and 23. So we have to measure this distance. Actually there is no need to measure this distance because it is already a given distance, that is the dimension for the link AB. So we have to put this as it is. Okay. So once we make this calculation, we get the angular velocity of link BC, that is omega 3 is equal to 21.665 radian per second. So this is the complete solution for your problem. So this is the end of the velocity analysis by instantaneous center method. Now in the next lecture we will see the more difficult problem or the practical problem for the location of instantaneous center of rotation by using graphical method, that is instantaneous center method. Thank you.